Section 3.5 is derivatives of trig functions. Again, this is going to be review, so we're going to go through pretty quickly. I'm not going to do a lot of examples or explanation. So the derivative of the sine function, so the derivative of sine x is cos x. These are ones that we should already have memorized. The derivative of cos x is negative sine x. So let's take a quick look at an example using sine and cosine. The derivative of sine x over cos x minus 2, we're going to need the quotient rule here for derivatives. So dy dx is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So again, cos 2x, the derivative of sine x is cos x. We're putting that into place. The derivative of cos x minus 2 is negative sine x plus 0, which we don't need to write. And we're going to just clean things up a bit, doing some distributive property here and multiplying here. And then looking for this identity, which is our sine squared plus cos squared equals 1. So factoring that, or putting those together so that we can use this identity, and then simplifying the numerator. So a simple example using sine and cosine derivatives. Harmonic motion. The motion of a weight bobbing up and down on the end of a string is an example of harmonic motion. Harmonic motion are our sine and cosine curves. So here's an example. A weight hanging from a spring bobs up and down with position function s equals 3 sine t. What are the velocity and acceleration at time t? So velocity is the first derivative of position. So velocity is ds dt, which is 3 times the derivative of sine, which is cosine. And then acceleration is dv dt, or the second derivative of position. We could also call this d squared s dt squared. And that's 3, again, our coefficient. The derivative of cos t is negative sine t. So again, a pretty simple use of our derivatives of sines and cosines. Jerk. Jerk is the fourth step, or the derivative of acceleration. So j of t, the jerk, is the derivative dA dt, or again, the third derivative away from position. That's off the screen a bit, sorry. Derivative, that says derivative of other basic trig functions. So the derivative of tan is secant squared, cotan is negative cosecant squared, the derivative of secant is secant x tan x, and the derivative of cosecant is negative cosecant x cotan x. Again, these are all rules that we should have memorized from AB. And that is it, pretty simple.